do on the fly. Okay, so if you remember, our new tool is integration by parts, okay, which means if I have the integral of u dv, what's that going to be equal to? Sarah? Excellent. Okay, and the tricky part is figuring out what you want u to be and what you want dv to be out of your original integral. And remember that the whole point here of substitution, of integration by parts, is to turn the integral that you have into something that you can look at and go, oh, that's sine x. Okay? And so that's what we're using our tools for. So we did a simple example yesterday. We started working on a more complicated example before the bell rang. So we're in the middle of page 350, number 8. And so we had the integral of x squared cosine x over 2 dx. And when we come to an integral, what's the first thing we ask ourselves? Inspection is my word, but yes, observation works, okay? So can I look at that integral and say, yeah, I know what that is? Can we do that? No. What's the next tool in our toolbox? Substitution. Where do we look for u's? In the argument of a trig function, under a radical, denominator, something raised to a power. Okay, I think that's most of them. So, and we talked about this yesterday, even if I substituted in for x over 2, that's not really going to help. That's just going to give me something like 4u squared cosine u du, which isn't going to make my integral any simpler. And we talked about how that's the whole point, is to make the integral simpler. So we decided we were going to have to go with integration by parts. We talked about how if you have a polynomial, and granted that is a very simple polynomial, but that if you have a polynomial and something that you can integrate, it probably makes sense to let the polynomial be your u, because you're going to take the derivative, and every time you take the derivative, what happens to the power, what happens to the leading power of the polynomial? It decreases. Okay, so eventually, if we apply integration by parts enough times, it'll go away. The polynomial will be gone altogether, and I'll just be left with whatever the other thing is, which is a cosine function, and I can integrate that. So we let u be x squared, we let dv be the cosine x over 2 dx. To integrate the cosine x over 2 dx, we did a w substitution, which is just like a u substitution, except I already used the letter u, so I had to use a different letter. All right, so we wouldn't get confused. So basically what we ended up with after we substituted in was that v was equal to 2 sine x over u. All right, everybody with me? Okay, everybody got it? So now we have to remember what it is that we were doing. So we had this integral x squared cosine x over 2 dx. I'm going to use integration by parts. I've identified my u, I've identified my v, I've got my du, I have my dv. Sarah told us that the integral of u dv is what? uv. Okay, so let's start. uv, okay, but it's uv. So remember, my u is x squared. My v is right here. Minus the integral of what? v du. So here's my v, 2 sine x over 2, and here's my du. Okay, so there's my new integral, or my new equation. So this part's cool. No integral, nothing I got to worry about. But I'm going to need to evaluate this integral. Let's write that integral down again, shall we? So it's going to be the integral of 4x sine x over 2 dx. Is that correct? Did I copy it right? Because I'm remembering it in my head. So you have come to an integral. What's the first thing you do? By inspection. Can you take the antiderivative of that by inspection? No. I can certainly pull the 4 out. So if I can't solve it by inspection, what's my next trick? Substitution. This looks suspiciously like what I had in the first place. Am I going to be able to use substitution? No, not really. It's going to give me like 2u sine u du. I don't know, there's going to be factors of 2 in there. Still not going to help me. So what do I have to do? What's our... Well, no. Substitution is the opposite of chain rule. What's the only other tool that I have in my toolbox? That's not what it's called at all. Integration by parts. So in this problem, to answer this problem, I have to do integration by parts a second time. So we got to start again. I've got to pick my u. I have to pick my dv. What would be a good choice? I think u equal x is a good idea. dv, whatever's left. Well, I would recommend you do it in my order every time. Hang on a minute. Okay, so remember how we let the polynomial be u the first time? What's going to happen this time when I take my derivative of x? I'm going to get dx, and now my polynomial's gone. So what was the order of my polynomial originally? To the second power. So, and how many times did I have to apply the product rule? Or I'm sorry, the integration by parts? 2. So whatever that leading power is going to be, that's the number of times you're going to have to apply integration by parts. Okay? Because every time the power goes down by 1. Now remember, over here for dv, now I have to take my integral so that I can get v back. So you might be able to do that in your head, but I'm not sure everybody can do it in their head at this point. So I myself, before I found v, I would have to take a little side trip and do a little w substitution here, just like we did in the first part. So if we let w be equal to x over 2, what's dw going to be? Glad we learned something from yesterday, because I believe this was a sticky point. Okay. So my integral becomes the integral, well, 2 times the integral of sine w dw. Yes? Because I have to solve this for dx, and dx is equal to 2 dw. You with me? All right, so, and of course, the integral of dv is d. Okay. And again, I believe this was a sticky point yesterday. What's the integral of sine w dw going to be? No, absolutely not one. Think it through in your head. Don't blurt something out until you've thought it through. Hang on, Zoe. Let everybody else think. Hang on. I know. Let everybody think it through for a second, then we'll see if we all agree. Zoe, what do you think it is? Not you, Zoe. Her Zoe. You're Zoe. I work really hard at making that distinction. Zoe L. Is she right, Zoe? But I work really hard at calling you what you want to be called. She was just eager to answer the question. All right, so do we all agree, everybody who thought about it in their heads? I know Rebecca was thinking. I know Sarah and Priya and Zoe were thinking. Okay, so my V is going to be -2 cosine, remember you have to substitute back in, x over 2. This is one of those days when I wish I could use my whole board again. Okay, so remember, this was the integral we were trying to solve. So let's write that again. Okay, so I've got 4 times the integral of x sine x over 2 dx. Move that over. Okay, so this is integration by parts. And what's integration by parts equal to? What's my formula? Minus. Okay. Again, remember we talked about writing it over and over again and how that's an important thing to do so that you remember it and you learn it. So if we flip back here, what's u? U is x, and what's v? Okay, so I'm going to have -2x cosine x over 2. There's no times. Okay, you know I like to put my negative sign and my constants out in front. I tend to end with the trig function, so there's no question over what's the argument of the trig function. Okay. Minus, what's my v? We got it? Is that what it is? Okay. Well, so we've still got -2x cosine x over 2. We can clean this up a little bit, right? My negative signs cancel. I can bring my 2 out, and I've got cosine x over 2 dx. That seems vaguely familiar. Have we done that integral before? Yesterday or today? Oh, I'm fairly certain we've done it with cosine x over 2 as well. So what was the answer? No. Yeah, good call, Sarah. You got my back. Thank you. No, I think we're actually going to be okay. No, this is the last piece, and then we got to put the whole thing together. Okay. Not worry about it. Well, there's a quiz next week, I believe, Wednesday. That's why you need to practice using the sheets that I gave you. Okay. All right, so let's put this whole puppy together here. All right. So our original integral at the very beginning was x squared cosine x over 2 dx. Okay. And that was, so here it is again, that was this. So that's going to be minus 4 times, and I believe I have negative 2x x over 2 plus 4 sine x over 2. Oh, wait a minute, except of course that there should be, what, a cosine there? Okay. I do want you to multiply everything out in case there's something we can combine. Did I do something wrong? Sarah, am I okay? It was so here and here, I had 2 and multiplied by 2. So when I took that integral, it was 4x, and then I took it out so that it was out here, and then I just focused on that integral. And so when I got over here, here was the 4 times my integral. And so I did all this stuff on the inside, but I still have to multiply by that 4. If I'd had the whole board, it would have been a little easier to see all the pieces. All right, let's try it again. Okay. So my initial integral was x squared cosine x over 2 dx, right? Okay. And that became 2x squared sine x over 2 minus 2 times the integral of sine x over 2 times 2x dx, right? Okay. So my first term here, nothing happened to it, right? Okay. I pulled out a 4, so it was minus 4 sine x over 2 with an x in front dx, right? With me? Sorry, I'm more worried about. Okay. So again, I leave this here. Yes. I think it came from the derivative. Okay. So now I'm going to apply integration by parts to here, my u's and my dx's. Okay. So when I take uv, I get minus 2x cosine x over 2 plus the integral of 2 cosine x over 2 dx. Okay, you got to find the different parts in your notes. Okay, still with me? Okay, so I've got 2x squared sine x over 2 minus 4 minus 2x cosine x over 2. And then when I figure that out, we got plus 4 sine x over 2 plus c. Oh, this 4? Oh, well, I had a 2 already, right? And so if I do the w substitution again, then dw is 1/2 dx, and dx is 2 dw. So my integral becomes, I still have this 2, but then I have, sorry, wait. dw, I'm sorry. So then this becomes cosine w times 2 dw. Okay, you good? Although I think there's a lot to be said for doing it out this way anyway. Okay, and then we can just multiply things out. Okay. No, I can't really add anything together. But I think it's better without parentheses. All right. We okay? We good? We got it? All right. Then let's try a couple more. So let's try page 351, number 30. Somebody read it for us, please. Okay. So solving the differential equation means that I want to find y as a function of x. So the first thing I need to do is rewrite this as dy is equal to x squared natural log of x dx. And as a sneak peek for what we're going to do after the AP exam, this, I believe, is a separable differential equation because I can get all my y's on one side with the dy, all my x's on the other side with the dx. And we'll spend more time with differential equations after the AP exam. Of course, there's an after the AP exam. We get to do fun stuff. Okay. No. There's just homework. There's no more tests after the AP exam. In my classes, at least. Okay. All right. So let's do what we got to do here. Okay. So the integral of dy is I. And then I've got my integral of x squared natural log of x dx. So I've come to an integral. Rebecca, what's the first thing I ask myself when I come to an integral? Right, can I just look at it and go, oh, inverse cosine? Can we do that? No. Gianni, what's the second thing I do? Yeah, use substitution. But again, is this really going to help me? What am I going to, where do I look for u's? So then I'm going to have u times the natural log of radical u. No, it's not really going to work. Okay? No, it's not going to work for you. Not going to work. Okay. So u substitution isn't really going to work for me. So what do I have left in my toolbox? Integration by parts. And so remember that the tricky part of integration by parts is figuring out u and dv. But remember two things. Number one, remember that the point of integration by parts or substitution is to simplify your integral into something you can recognize and go, oh yeah, I know what that is. But you also have to remember that whatever you choose for dv is something you can actually integrate. So Zoe, did you have a guess for us here? As what?
That's what I was saying before. Or did I not say it right?
Did I see another hand? I thought I saw somebody's hand up. So what's du going to be? And then I'm going to integrate here. And what's v going to be equal to? That would be the derivative of the natural log of x. It's an excellent question, Priya. What has a derivative of ln of x? No, what's the derivative of e to the x? E to the x. No, you're not going to Google it. No. Dude. Well, I don't know if you're worthy of knowing this too early. I don't know about you guys. In the back of your book is a table of integrals, which nobody ever finds, and we're not going to use it. There might be the integral of natural log of u du in that table of integrals. So you can look, but we're not going to use it. 100 or so? So I don't know. It might be in there. No, I don't know what the integral of natural log of x dx is. We could do that. It might be, I mean, we're not going to use it even if you find it.
I found ln x. I did find something.
What's the integral of ln x dx?
Well, I was going to say what to. It says the integral of e to the ax. Oh no.
Nope, that's not it. Maddie, what do you got? Yup. So you have to remember that whatever you let be dv is something you can integrate. It was an exploration. I can't correct all of your mistakes because then you'll never learn. Don't. I let you guys make your choices all the time. So we're going to let u be equal to natural log x. So what's du going to be? Times dx. So dx over x. And then what's dv going to be? So Maggie, what's v going to be? Just take the antiderivative. Reverse power rule. Now x to the over 3, right? I know you had a day away from us and you lost it all, but that's okay. All right? Yes, we assumed that you filled in your journal. Yeah. But that's not true because Sari and Sarah had it. I had them redo a journal problem that I assumed nobody had done, but we did say if you'd been here, you had done it, and Sari had done it, and Sarah had done it. So, yeah, no one else did it. All right. Excellent. So, x squared natural log of x dx. What's the first thing I write down? No. uv, right? So that gives me x cubed over 3 natural log of x. Is it a plus or a minus sign? I know that. Wait, what? It's okay. It's a Leo thing. Leo frequently says, wait, what? He's 8, it's just what he says. All right, so now what do I put? Of yeah. What? I could, but why would I want to do that? Oh, definitely. I'm just going to cross out the x's anyway. So I've got x cubed over 3 natural log of x. I can definitely pull out the 1/3. I can definitely cancel and make it x squared dx. And what was the whole point of integration by parts? Making it simpler. Rebecca, what don't you like? What have I messed up here? Talk. I'm sorry. I want to answer your question. Could you talk louder because the thing is making noise? The integral of u du. You mean v dv? Like that? No. Right, so this was uv minus v du. And v is x cubed over 3, and du is dx over x. Are you with you there? You got it? Okay. Okay, so remember that the whole point was to come up with an integral that we could solve just by looking at it. So can I solve this one just by looking at it? Maddie, what is it? Over 3. And of course I've got my plus c. So I end up with x cubed over 3 natural log x minus 1/9 x cubed plus c. Which I'm assuming is the right answer. Sure. Okay. Well, that was the whole idea, is that things were going to get more complicated. But there was a different lesson in this one. All right. Things I want